आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
We bring you all a podcast series on STEM popularization, that is, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation.
Welcome back to the podcast from the Indo French Center for the Promotion of Advanced Research, CEFIPRA. In this episode, we continue to explore the fascinating collaborations between Indian and French scientists that are pushing the boundaries of knowledge. Now let's explore more with them.
Hello, I'm Mythily Ramaswamy. I had finished this project, CEFIPRA project, from 2008 to 2011. This was control of systems of partial differential equations with Professor Jean-Pierre Rameau in Toulouse University. And this was a very interesting project for our group. We learnt a lot about the PDE control. We trained 2-3 of our students now, and they have also taken over. They are continuing with this direction. And this is where we started with Navier-Stokes equation, fluid models, and their controllability, stabilizability, stability issues. All this we learnt in this project, and this was a very useful and successful project. I am very happy with CEFIPRA for funding us for this. This project was particularly helpful for our group because CEFIPRA allowed students also to go for 3 months stay, which was remarkable because at that time I had actually 3 PhD students, and so I could train them here to introduce them to the topics, and so they were quite well prepared. And so when they went to Toulouse University, they could interact with the PI from the French side, Jean-Pierre Rameau, and also they had exposure to the French students, postdocs, and the whole group. This was a very, very important experience for my students. So that is what made them launch into a research career with confidence, and now they are continuing in this subject because they had a very good foundation in Toulouse University with the active research group. So I am very thankful again to CEFIPRA for introducing the student component, which was new at that time, and we thoroughly profited from this. Now I'll say a little bit, and also of course the French visitors were coming regularly. Every year the French visitors were coming. This was also very helpful for not only my students but for our group, because we didn't have control of PDE at that time very much done in India, actually not in many places. So it was a totally new topic for the entire student community, research community, let me put it. So it was a very useful, productive time for all of us. It was an exciting period for our whole group. And so I could also go periodically. So I used to work on this Navier-Stokes equation. We took up the compressible Navier-Stokes equation, which was a difficult system because it was a mixed types of PDEs. It was mixed type of parabolic as well as an ODE type or hyperbolic. So because two types of PDEs were mixed, it was not clear to us which kind of control tools will be working, because each type of PDE will need a different set of tools to study the problem. So we had to work a lot to find out how the mixture of the two will work in this problem. So this was also very exciting for the whole group. Actually 3 theses came out of this project, and I'm very happy to add the 3 students are now faculty. Shirshendu is in ISER Kolkata. He is still continuing through the next CEFIPRA projects. And Devanjana Mitra is a faculty in IIT Bombay. She has currently gone to Bordeaux and Toulouse to continue in research in the current project which we are running. And the third student is Debayan Maiti, who is a faculty in TIFR Center. He is also doing very well in this subject, and he is also planning to go in next month again in the same project which is about to end in March. So that way not only me, our whole student community is very thankful to CEFIPRA for having this, allowing the students to stay for 3 months at a stretch, and they were treated like students of Toulouse University, which allowed them to mingle easily and get exposed to the various lectures, seminars and conferences happening in Toulouse University. This was a wonderful experience. So once again, my thanks to CEFIPRA. So in this project, together with Jean-Pierre Rameau and my students, we have shown that the linearized system, as I told you earlier, we were looking at compressible Navier-Stokes system in one dimension. So we linearized it around constant steady states. Earlier this system was not well studied, so we had to understand the stability aspects, as I told you before. So around the constant steady state, if the velocity is 0, in a bounded interval, we proved it is approximately controllable, but it is null controllable, which means it can be pushed to 0. The fluid will come to rest only when the control is applied everywhere on the domain. On the other hand, if the constant steady state has non-zero velocity, then we showed the system will be null controllable using even localized control. That is, it's enough to control anywhere in the fluid region with with less regular controls. We were able to show that it was null controllable. Then we took up the stability aspects. The linearized system around null velocity is stabilizable with a certain rate of decay, but this decay was determined by the accumulation point in the spectrum, and this was shown to be sharp. That is in our paper. The full nonlinear system later on we showed that was also locally stabilizable near this constant steady state, both null velocity as well as non-null velocity. We did that using a feedback control which was coming from the linearized system. Here the crucial point was we realized we needed a change of coordinates, and this was one of the first results for the nonlinear system, that was for compressible Navier-Stokes. This was at that time a few results available for the control of compressible Navier-Stokes system in the literature. And we are happy that we could give the complete behavior of the linearized system as well as the nonlinear system near the constant steady states. And we also established this with only one control for velocity that was enough to control the system. And there are well-known techniques for separately for transport equation and or parabolic equation. Compressible Navier-Stokes system being a coupled system of transport and parabolic type, tackling the regularity, the control issues, they posed serious difficulties. And so the result of our project is how to handle these kind of mixed type of PDE systems.
This episode is brought to you with the content support from Cefipra and the technical support from the Sparrows team. We extend our heartfelt thanks to the Director of Cefipra, Professor Nitin Seth and Dr. Payal for their continuous guidance and support. Stay tuned for more episodes and thank you for joining.
आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी